Hey everyone, and welcome back to AI Paper Podcasts. We're diving deep into LLM2Vec. Large language models are secretly powerful text encoders.
Oh, this is a fun one.
Yeah, it is. This paper is making waves because it really challenges, that whole assumption that decoder-only LLMs aren't really great for text embedding tasks.
Yeah, exactly. And these tasks need rich text representations, and the authors Behnam, Goddard, Adlaka, Musbach, and their team show how to transform decoder-only LLMs, like, Llama and Mistral, into universal text encoders using a surprisingly simple and efficient method.
And they get some pretty amazing results.
Yeah.
They boost performance on things like word-level tasks, like chunking NER and POS tagging, even outperforming some strong encoder-only models.
Yep.
And plus, they actually set a new state-of-the-art for unsupervised models on the MTEB benchmark.
Absolutely.
But really exciting stuff.
It is. The key takeaway here is that, LLM2Vec unlocks the potential of these really powerful LLMs for a wider range of tasks.
Yeah. And it's really all about how we could adapt these models for more diverse applications and research directions.
For sure.
Now let's get into the paper itself.
Okay.
So first up, the introduction. They highlight this problem.
Yeah.
Decoder-only LLMs, while great for text generation, rely on causal attention.
Yeah.
They're processing text in one direction past the future.
Right, so they only look at past tokens.
Exactly.
Which is perfect for predicting the next word, but not ideal for capturing the full context needed for, text embedding tasks.
Yeah, it's like reading a sentence, but only remembering the last word you saw.
Exactly.
And this limitation is why decoder-only LLMs haven't been widely used for things like, sentence similarity or information retrieval.
Yeah, makes sense.
So in the related work section, they discuss how previous approaches have tried to address this, including techniques like sentence transformers or using pre-trained sentence embeddings.
Yeah.
However, these often require lots of labeled data, or they just aren't as efficient.
Right.
And this is where LLM2Vec comes in.
Okay.
They introduced their novel method, which builds on SimCSE,
Yeah.
which is a contrastive learning technique,
Right.
and combines it with a pretty clever training approach.
Yeah, it's a three-step process.
Okay.
First, they unlock bidirectional attention, allowing the model to look at both past and future tokens.
Right, so giving it a wider perspective.
Wider perspective, exactly.
But as you might guess, just turning on bidirectional attention doesn't magically improve performance.
No, it can actually make things worse.
It can make it worse.
Yeah.
So that's where the second step comes in.
Right.
Masked next token prediction, or MNTP.
And then MTP.
They train the model to predict masked tokens using the entire sentence,
Okay.
forcing it to learn how to use this newfound bidirectional power effectively.
Right, so it's like teaching the model to fill in the blanks while considering the whole picture, not just the words that it's already seen.
Exactly.
So that MNTP training is crucial. And then the third step is fine-tuning using unsupervised contrastive learning, specifically SimCSE. And this helps learn even better sentence representations for those text embedding tasks.
All right.
All without labeled data.
All without labeled data. That's pretty awesome.
It is.
So let's move on to the experiments and results section.
Okay.
They apply LLM2Vec to several LLMs, including SLAMA GON 1.3b, LLMA 2.7b, Mistral 7b, and MetaLlama 3.8b.
Nice.
Pretty standard, large language models that we're all familiar with.
Yeah, very popular these days.
And the results are pretty impressive.
Yeah, they are.
They test on various downstream tasks, both word level and sentence level, showcasing LLM2Vec's versatility. So in word level tasks like POS tagging and NER.
Yeah.
The LLM2Vec transform models actually outperformed even strong encoder-only models.
Really?
Yeah.
That's awesome.
It is. And this tells us that LLM2Vec helps create really rich token representations, capturing more nuanced linguistic information.
Yeah. It's really interesting to see how it kind of unlocks that potential in those models.
Now, on the sentence level, they tested on the MTEB benchmark.
Yeah.
LLM2Vec set a new state-of-the-art for unsupervised models.
That's a big deal.
Yeah, it is a big deal.
Because it shows that you can achieve top-tier performance without relying on tons of labeled data.
Exactly.
Which is always a challenge.
And they also explored some supervised settings.
Okay.
And found that LLM2Vec actually exhibits this impressive sample efficiency, needing less labeled data for good performance, which is a huge advantage, especially when you're dealing with low resource scenarios or specialized domains.
Absolutely.
Now, there is one kind of intriguing finding.
Okay.
With Mistral 7B, it actually seemed to handle bidirectional attention well.
Oh, interesting.
Even without any MTP fine-tuning.
So it's like it already knew how to do it?
Yeah. It was as if it already knew how to do it. Like, what's going on here?
Yeah, that's weird.
So the authors speculate that Mistral 7B might have been pre-trained with some form of bidirectional attention, perhaps through prefix language modeling.
That's possible.
But this detail wasn't publicly disclosed.
Right,
so
it's a mystery.
It is a bit of a mystery.
Yeah.
And it highlights how much we still don't know about these models.
Absolutely. There might be more surprises waiting to be discovered.
You never know what these, black boxes are doing.
Exactly.
Now, moving on to the analysis section.
Okay.
The paper delves into how LLM2Vec actually changes the model's inner workings. So they wanted to understand how the model incorporates information from future tokens after enabling bidirectional attention.
Yeah, makes sense.
So they designed a clever experiment using sentences that shared the same prefix but had different endings.
Okay.
So they were testing whether the model could leverage the future context to distinguish between sentences with different meanings, even when they started the same way.
Yeah, that's a good test.
And they found that the LLM2Vec transformed models were much better at this task.
Cool.
Demonstrating that they were indeed using information from the entire sentence, not just the past tokens.
Yeah.
So this provides strong evidence that LLM2Vec truly enables the model to utilize bidirectional information effectively.
So it's not just a fluke, it's actually doing what it's supposed to do.
It's doing what it's supposed to do.
That's great.
To further investigate the Mistral 7B anomaly, they compared its internal token representations with and without bidirectional attention.
Yeah.
Now, for S-Llama and Llama-2, the representations shifted dramatically when bidirectional attention was enabled.
Yeah, that makes sense.
But for Mistral 7B, the representations remained remarkably stable, suggesting that it was already processing information bidirectionally.
Wow.
To some extent.
That's wild.
Yeah, it is.
So it's like it had some kind of pre-training or something.
It had some kind of implicit training going on that we don't know about.
That's fascinating.
So this supports their hypothesis that Mistral might have received some implicit bidirectional training during pre-training.
Yeah.
It's a fascinating finding.
It is.
That warrants further investigation.
I agree.
Now let's talk about the practical implications of LLM2Vec.
Yeah.
They highlight its efficiency, particularly the fact that it uses parameter-efficient fine-tuning.
Right.
Making it feasible even for researchers with limited computational resources.
That's huge.
So this is a really big advantage because it democratizes access to this technique.
Yeah.
Allowing a wider range of researchers to experiment and benefit from it.
Absolutely.
And they also show that LLM2Vec outperforms the echo embedding method.
Okay.
Which duplicates input sequences to achieve similar results. But duplication adds computational overhead.
Right.
So LLM2Vec offers a more streamlined approach.
So it's more efficient.
Much more efficient.
That's great.
Now, in their discussion section, they emphasize that LLM2Vec is not a one-size-fits-all solution. So the choice of the pre-trained LLM, the hyperparameters used for fine-tuning, and the specific downstream task all play a role in determining the effectiveness of the approach.
So it's not just plug and play. You have to kind of think about it and tune it for your specific task.
It's important to consider these factors when applying LLM2Vec to your own work.
Right.
Some experimentation and fine-tuning might be required.
Yeah, for sure.
They also highlight some of the limitations of their work, acknowledging that there's still room for improvement.
Makes sense.
So, for example, they suggest exploring different pre-training techniques that might further enhance bidirectional capabilities.
Yeah, that's a good direction for future work.
Finally, in their conclusion section, they reiterate the significance of their findings, emphasizing that LLM2Vec opens up a whole new world of possibilities for utilizing decoder-only LLMs.
It's like a paradigm shift.
It is a paradigm shift.
In how we think about these models.
Exactly.
Showing that they can be highly effective for a much broader range of tasks than we previously thought.
They also point out the intriguing questions raised by Mistral 7B's unexpected bidirectional capabilities, urging the community to investigate these further.
Yeah, we need to get to the bottom of this.
We do.
Yeah.
Seems like we've only just scratched the surface.
Oh, yeah.
Of what these large language models can do.
For sure.
Pretty exciting.
Yeah.
LLM2Vec isn't just a neat trick.
No.
It's a fundamental shift in how we think about and utilize these models.
I agree.
And this paper really lays the groundwork for, a whole new wave of research and applications.
Absolutely.
And it underscores the importance of carefully examining our assumptions.
Yeah.
About these models. Like, who knows what other hidden talents are lurking within them.
Exactly.
Just waiting to be unlocked.
It's really exciting to think about.
Yeah. What else is out there?
Yeah.
So,
it's like the Wild West of AI right now.
Yeah, it is like the Wild West.
There's so much to explore.
So much to explore.
So much to discover.
And this paper is a fantastic example of how a simple yet insightful approach can lead to significant advancements in the field.
Absolutely. Yeah. I think this is a really important paper.
I agree.
For people to check out.
I think we've covered all the key points.
I think so.
Of this paper.
Yeah.
A big thank you to the authors. For this insightful work.
Absolutely.
And for our listeners out there.
Yeah.
What are your thoughts on LLM2Vec and its potential impact on the field?
Yeah.
Let us know in the comments below.
I'd love to hear it.
Till next time.
See ya.